Alrighty, so in this video, we're going to take a look at solving binomial probability using the Ti84. So essentially in the Ti84, you need to either use the binomial PDF or binomial CDF. In order to get the binomial PDF or CDF command, you have to first select second vars on the calculator. Oh, sorry. Second vars. There we go. And underneath distribution, you would either select binomial PDF or binomial CDF. You will select binomial PDF whenever you see the word exactly, right? So one of the keywords or phrases from this problem, which I haven't read yet, is going to be the word exactly. Oops. So when you see exactly some value, we're going to use the binomial PDF command. If I see at most, less than, at least, or more than x, we will need to use a binomial CDF command. And since C stands for cumulative, there's a certain way that you have to enter the values. For example, for at most x or less than x, all you would need to do is enter the values of npx or np and x minus 1. For the at least or more than, you would have to begin the problem by doing 1 minus binomial CDF npx minus 1 or npx. The reason why that there's these 1 minus that goes first is that for the at least and more than, you apply in stats, you learn about the complement rule. So basically, if you want to find at least x, for example, you would have to do 1 minus its complement, which is less than x. If you have to find more than x, you do 1 minus binomial CDF of the at most x. All right, so here it goes. For problem number 5, it says that 52% of US adults have very little confidence in newspapers. You randomly select 2 US adults, you randomly selected 10 US adults. Find the probability that the number of US adults have very little confidence in newspapers is, in part A, exactly 5, part B, at least 6, and part C states less than 4. So when you're going to read part A, the first thing that you would like to do is make sure that you can label out your N, P, and X. N is your sample size or total number of trials. So in this case, N is going to be 10. P stands for your success rate. And the success rate in this problem is going to be the 52%. Now, for computation purposes, namely entering 52% in the calculator, you will need to convert this to a decimal, which gives us 0.52. Now, in part A, it states exactly 5. So x is going to only equal to one number, which is, of course, 5. Now, in the calculator, this signifies that we will use the exactly, the keyword there or phrase was exactly 5. So that this tells us I do the binomial PDF command. So essentially in the calculator, I need to enter binomial PDF. In parentheses, I put the value of n first, which is 10, comma, the value of p, which is 0.52, comma, the value of x, which is 5. When I do this correctly in the calculator, I will just round it to, let's say, 4 decimal places. So let's see. So again, to get the binomial PDF command, I do second vars. Then I select binomial PDF. So that's option A underneath distribution. And I enter my values. So I have 10, comma, 0.52, comma, 5, close parentheses. So when I round my, oh, sorry, it didn't put the 10. Oopsie, gotta do it again. Binomialpdf 10, comma, 0.52, comma 5. There we go. So when I round this answer to 4 decimal places, we get 0.2441. And that will be your solution. So if you're doing this on the exam, for example, first thing that you want to pick out is the key phrase. Here it's at exactly 5. Write out the values of n, p, and x. And then you do the binomial, either a PDF or a CDF command. And part A is just PDF, because it's stated clearly exactly 5. For any other words, keywords, if it says at most, less than, at least, or more than, then you have to use the other commands. The binomial CDF. Andre, any questions?
I think I'm good for now.
Okay, so we'll continue.
I'm sorry. The only thing is that on my calculator, it looks a little different because it shows like the X and then the mean and then the standard deviation.
No, so I think you're using the wrong command. You have the Ti83 or 84?
84.
84. So you, again, you do second vars, but be careful. You're selecting, right? You're not selecting normal PDF or normal CDF. You're not selecting either one of these two. You got to scroll down.
Yeah, that's probably what I ended up.
Yeah. So it's either the one that says A or B. A is the PDF and B is the CDF.
Oh, so then it says like trials, P and
That's right.
Okay, yeah, I got it.
So your trials is your N, and your P is a success rate, and X is the exactly whatever number that you have.
Okay, got it.
Sounds good?
Yeah.
All right, let's continue. So that way you get the hang of it. In part B, it says that we have to do the at least 6. So in this problem, N and P are still going to be the same values. N is still going to be the success rate. And sorry, N is still the number of trials, which is 10. And P is your success rate, which is still going to be 0.52. Now, in this problem, we don't have X is equal to a number. What we have is that X is at least 6. Mathematically, at least means greater or equal to, right? So at least 6 basically means greater or equal to 6. So mathematically, we use the greater than symbol with the equal sign underneath. Okay. So for us, we have to use now not a PDF, but a CDF. And the way that the CDF works is that for at least X, we do 1 minus binomial CDF, NP followed by X minus 1. Let me write out that command with our values and I'll explain it. So what we have is that the probability of getting at least 6 is equal to 1 minus binomial CDF of the value of N, which is 10, comma, the value of P, which is 0.52, comma, the value of X minus 1. So if you think about your X starting at 6, 6 minus 1 is 5. The binomial CDF of 10, comma, 0.52, comma, 5 is precisely everything that is less than 6. Okay? If you think about it, at least means greater or equal to 6. So its complement or its opposite is going to be less than. What the binomial CDF does is that it starts at X equals 0 and is going all the way up to the number before 6. Okay, so this command here gives us less than 6, which, by the way, is the complement of greater than 6, greater or equal to 6. Now, the answer wouldn't be the binomial CDF part. You need to have the 1 minus in front of it because you're essentially applying a complement rule. So we get, okay, well, if I answer this in the calculator, we start by doing 1 minus second vars binomial CDF of 10, comma 0.52, comma x, which is 5. And if I hit enter, I get an answer. We get 0.4270 if I round it to 4 decimal places. And that will be it. Questions here?
Do you always subtract the 1? Like you see how?
It depends.
Okay.
It depends. Now, if it says at least or more than, then yes, you would need to do the 1 minus. If
Oh,
it
okay.
states at most or less than, then you don't have to.
Okay.
All right. If it says at most or less than x, you don't have to.
Okay.
Like, let's try it again. For part C, it stated less than 4. Right. We're trying to find the probability that basically less than 4 US adults have very little confidence in newspapers. So again, n stays the same. N is 10. P is going to be 0.52. If we use inequality symbols, we say x is strictly less than 4. So because x is less than 4, the only possible values for x are going to be 0, 1, 2, and 3. With the binomial CDF command, I don't need the 1 minus because, again, we're starting this time with 0. Okay. So here, the command that we're going to have is binomial CDF of n, which is 10, the value of p, which is 0.52, but I can't use x equals 4. I have to go 1 less than 4 because look at the way the inequality symbol is being written. This time it's going to the left instead of to the right, and we're not including the 4. So what's one number? What is one number directly underneath 4? It's going to be 3. Yeah, you can. All right. So it's binomial CDF 10, comma 0.52, comma 3. So you do second vars, binomial CDF 10, comma 0.52, comma 3, close parentheses. And you get an answer. If you round this to 4 decimal places, what do you get? Excuse me. We get 0.1410. Let me know if you have any questions.
I'm good for now.
Okay. I have one more example. Let's just do it to get it out of the way. Okay, so that way we get the hang of it. Problem number 6 states that the technology notes stays the same as problem 5. We're still dealing with binomial probability. And the problem reads 30% of consumers prefer to purchase electronics online. You randomly selected 8 consumers. Find the probability that the consumers who prefer to purchase electronics online is exactly 5, more than 5, and at most 5. So to start part A, we have exactly 5. That's the key phrase. So exactly 5 would imply that I have to use a binomial PDF command. Okay. It's a single probability that we're computing. Now we need to label n, p, and x. So n is the number of people that was randomly selected, which is 8. Our p-value is 30%. Now, what is 30% as a decimal?
Point
30%,
30.
0.30, there you go. And the value of x is only one value, it's going to be 5. So for part A, we will have to enter binomial PDF of the value of n, which is 8, the value of p, which is 0.30, followed by the value of x, which is 5. So second bars binomial PDF. So I select option A this time. And then we do 8, comma, 0.30, comma, 5. Round this to 4 decimals. You're going to get approximately 0.0467. So that'll be the solution to A. Now, if you do this again for part B, we might get a different result. More than likely, it says more than 5. So let's do our labeling. For more than, would I need to do a binomial PDF or CDF?
CDF.
Careful, it's CDF.
Yeah, that's what I said.
Oh, I'm so sorry.
No, you got it.
So we're gonna have to use a binomial CDF command. So let's label our n, p, and x. So n is 8. P is still going to be 0.30. And x, if it's more than 5, then what symbol can I use? Can I use the less than, the not equal, greater than or equal to, the greater than symbol? What symbol I can use here?
Isn't it the greater than?
Excuse me, that's right. X is going to be greater than 5. Very good. So we just put back the 5 in green. All right. So how do I do this now in the calculator? Well, first of all, since we're doing a CDF command and we're starting at 5, right? X greater than 5 would mean that you got to do anything bigger than 5. So that would be 6. X is equal to 6, 7, and 8. So I need to use the 1 minus first, right? So in the calculator, we're going to do 1 minus binomial CDF of the value of n, which is 8, followed by the value of p, followed by either x or x minus 1. So how can I figure this out? Well, more than 5 means that it's the complement, the opposite of more than 5 is, excuse me, at most 5. At most would indicate that we're doing 5 or below. So I want to use 5 here, okay? So we do 1 minus binomial CDF of 8, comma, 0.30, comma, 5. So I entered in the calculator. So second bars binomial CDF, 8, comma, 0.30, comma, 5. And you get an answer. You can round this off to 4 decimal places. You get 0.0112 or 0.0113 actually, because the 9 will tell the 2 to go up 1. Okay, so that will be your solution for part B. And now we do part C. So part C, we have at most 5. By the way, at most 5 is exactly what I've written above, with the exception of the 1 minus. So I will need to do a binomial CDF here. In particular, n we know is to be 8. P is equal to 0.30. X is now less than or equal to 5, because x is less than or equal to 5 is the complement of more than 5. And again, all we need is just the binomial CDF of n, which is 8, 0.30, which is our p-value. Now, for at most 5, we are definitely including 5 here. 5 is where I'm stopping at. So I don't need to do the -1 here. So second vars, binomial CDF, 8, comma, 0.30, comma, 5. And we get exactly the complement of the previous answer. So it will be 0.9887. Okay, so those are your solutions to parts A, B, and C to problem 6.